Hey everyone, welcome back to my YouTube channel. So today in this video, we are going to learn about one of the most important concept in the world of AI, and that concept is known as RAG. Well, RAG is actually the concept which helped make Perplexity billions, which is behind one of the most important tech in today's world, that is making AI actually useful in industries as well as for our personal use cases. Now, most of the videos which I found in RAG made it very difficult. Via this video, I will make sure that I can explain you RAG with the most easy and intuitive example, so that if you're using any other AI in future or making any AI product as well, you could easily integrate RAG into your product. So with that, let's get started. So what normally happens, we normally are having some information. Now RAG also has, or RAG rather is a two-step process in a similar manner. Two-step process, right? The very first step is going to be, let's say, RAG pipeline to get or to store the data, rather to store the data. Now, just like in the example which I told you, how we were able to learn something. So the first step was learning, and then second step was recalling or retrieval, right? In a similar manner, RAGs also works in two step, right? What normally happen is that we have some documents, right? Let's say these are different documents, everyone. Now, I take each and every document. So I will be taking a document one by one, and I will be creating small and small chunks of that document, right? So, for example, you can give me 100, let's say 100 documents. One by one, I will take some documents, and I would like to now break that document into small chunks. So that is the whole basic idea. First, let's see the overall learning or the RAG pipeline to store the data, right? Once I have done this, after that, what I will be doing is that these different chunks which I have, I will try to map them onto a graph via making their embeddings. Now, to explain you about what embedding is, now these chunks, they can be, let's say, text, images, or rather any form of data, any form of data. But my computer only understand numbers, so I will be trying to make sure that I can convert this into numbers. Now, once I have converted this into numbers, then I will make sure that somehow I am able to create different chunks for them, right? So one data can be here, one data can be here, and again it can be based on different dimensions. So there are different overall techniques via which we can create these embeddings. We can create these different overall chunks. You just have to understand that yes, once when I break my data into chunks, I'm able to store that data in a way which I want, right? So that is the whole process. And this thing is known as vectorization. So, vectorization, I hope all of you remember how some image or something we are able to change into a vector like this. So, it can be, let's say, 1.0, it can be 2.5, it can be minus 5.6, something like this, right? And again, it can be an n dimensional vector, totally dependent on how we are vectorizing them. So, based on some logic. Now, a better understanding of this can be that we have this kind of a image which you can understand, right? So pay attention here. Now here, what is happening? Let's say this is a RAG overall ingestion thing which I have created. Each dot here is representing a chunk. Now the whole idea is that if our algorithm is pretty good, then similar chunks are going to end up together or close to each other, right? The whole idea is that if or when I'm creating chunks, those chunks will be created in a similar or with a some brain in mind, right? So we have again different embedding techniques via which we embed our data. So embedding, you can just think that hey, whatever text you have, you're just converting that text into numbers, right? So that is just what embedding is. A very easy to understand manner example of this, right, everyone? So let's say that if I ask you what is uh, cosine. Okay, what is cosine? I hope all of you will say that it is something related to maths. Or let me make it easy. What is, let's say, LBW? What is LBW? It is related to cricket, everyone. Right. Now, let's say that I ask you about, let's say that I ask you about DRS. It is also related to cricket, right? Make sense? Even if you don't think about this, let's say that you have different pages, right? You have pages just in front of you, right? You have these documents which is there in front of you. Now, since you are having mind, since you are having some brain, won't you be somehow based on your knowledge, won't you be combining the similar documents together or around each other? So I can say that, okay, documents related to cricket, they will be nearer to each other, just how we do it in a library as well. Just like you have it in a library. Like, again, you have to understand one thing, that when you also combine the data, that data is getting combined via overall some logic, some brain is coming into that data. It is not that we are just creating this overall graph by pushing out anything anywhere, right? So because I'm having that mind, I will be making sure that goal, and let's say goal, which is there in soccer, and then let's say something like uh, offside, which is also there in soccer, I will be still placing around each other. So they will be around each other because I'm creating these things with a mind, with a brain. Okay. In a similar manner, let's say if I have some documents or some books related to soccer players, soccer rules, they will be somehow getting together, characterized in a similar space. Because again, I will repeat, I am creating these embeddings with some brain, embedding models, right? And these embedding models, right? All of these embedding models are vectors that represent real world objects like word, images, or videos in a form that machine can easily understand. So if I go and show you in images, right? We pick up a data. We pick up a data. It can be again any simple data. It can be a audio. It can be a video. When we pass the same via a embedding model, then we are able to get some number form of the same, right? And these numbers I could easily make sure, and maybe I can plot that, or I could make sure that I could just compare those numbers, right? Now, just if we try to understand it, don't you think that the data which is similar will be having numbers which are very close to each other? Yes or no? If this data of, let's say, similar thing will be having the similar embedding, then when I will try to somehow create a graph or a let's say overall this particular 3D or let's say ND kind of a diagram, then we can surely say that things which are closely related to each other, they will be coming close to one another because they are having these numbers similar to one another, right? Because they are having these numbers similar to one another, when we make sure that, okay, these vectors, when we are plotting them, similar vectors will be coming towards a similar or close to each other. So this is exactly what happens in the learning phase, where I am able to vectorize my data. Now again, there are different other ways of as well instead of vectorizing. But the whole idea is that I am able to vectorize my data. And once my data is vectorized, then I could easily create these embeddings. And these embeddings, they can be used, right? So for example, here I have created these embeddings, and you can see how similar color embeddings are close to each other. Now, this color can be any factor, right? Or let's say this can be some books, etc. And one more thing to understand is that these embeddings, they can be wrong as well, totally wrong as well. It just depends on how good our embedding model is. As an easy example, what I'm giving you is that give 100 books to a 7-year-old or 8-year-old, he will randomly assign them. Give 100 books to a librarian, he or she will make that it is very very nicely together, overall given, right? And then when you ask that 7-8 years old book, hey, that this is the book which I want, he might not able to give you. Librarian might give you a book in a second. So again, with this example, pretty sure that this should be a lot clear. And this is the whole process overall of creating our embeddings. This is the whole idea of creating our embedding. So this diagram will also make things a lot clear. You give images, documents, audio, whatever you want to a embedding model. Now, this embedding models changes them into vectors. Now, this can be a multi-dimensional thing. And then we try to just make sure that somehow we are able to map them into some space. Now, it can be 3D, ND, whatever space. But the idea is that once we have got the mathematical equivalent, we can easily create that. So that is the whole idea, everyone, that we are able to create our own embedding model based on this. So this is an interactive RAG playground. What all I've explained you here, now all the dots will get generated. You will get clear here. Okay. So see, this was the whole process which I explained you in the very first part. We will be getting a document, right? We can again take document one by one. That document will be divided into smaller chunks. Each of those chunks will be changed into a number. And then we are going to just make sure that we can plot those things, right? So let me start this experiment and let me show you. See, this is a very long text, right? Which is divided into different chunks, right? Now, chunking is just as you see in front of you, like how this whole data, it was divided into 26 chunks, right? Now there are again different chunking strategy as well. We can have a fixed character as well that, hey, I want every 500 characters should form a chunk. So here chunk size is 500, overlap size is 50. So overlapping just to make sure that this chunk has an idea what was before me, right? This is again where the overlapping things come. We can have a recursive character chunking as well. So different chunking ways, right? Now, in this sense, this overall data, this overall whatever was in front of us has been chunked, right? Because if you also remember, you don't learn the full chapter altogether. You divide it into chunks and learn the part. So with this overall concept of chunk clear, and again, I think this is very basic thing. We also learn in chunks, right? We also learn things in chunks. Then let's go on to the next part, which is the vector embedding. Now here I'm selecting an embedding model, right? There can be multiple embedding models, just one is supported here. It has created the model right in front of us, right? So if I go back and show, it is calculating these things, it is loading the model, and then it is creating these things, right? So here we have different chunks which we created, right? So let me first delete this for the timing. We are having different chunks here, everyone, right? We can see that how this text, this chunk one, it is having this overall as the mathematical vector, right? So just like how I learn things, I am having some brain, I have some paragraph, I divide that into chunks, and I keep those chunks nearer to whatever it was saying, right? So if you give me a paragraph, let's say related to something, I will also learn in the same manner. And this is what we are trying to understand. Now you see that how these chunks, they are having the mathematical way of them, right? And this is what I told you. So now these chunks, because they are having a mathematical way, I will be able to, right? I will be able to easily see or have their vectorization, a graph kind of a thing created. So let me just ask this. For the timing, you can just ignore this red one. But what you can see is that how different rags are coming here, right? How these different things are having or are rather coming here. That is the whole idea, right? So these different blue ones are the chunks which were created. And because I applied some brain, these chunks are having some data inside them. And I'm able to just plot them in a easy to understand space. So that is the whole idea. Now this is very much simplified, but the idea is this, that yes, we see these different chunks which are being created in front of us. So this is what happens when the data gets divided. So let's do an experiment. Let's have a very random line added here, right? So all of these has to do with this thing. Let's add a very random line here. Now this is a 54 chunk, most probably because other chunks have to do something with LLM, RAG, etc. And my 54 chunk, this one is having very random thing, right? So let's see this. Hopefully it will be very far off. Let's see the vector embeddings. So again, it is being created and we will see that how the whole has been kind of broken. Let's see the last one, what it was. Chunk 27, right? So chunk 27 will most probably be very far off. If we try to find it, it will be very randomly kept somewhere because it is not to do anything with any of these things, right? So if I just try to find it, where exactly is my chunk 27, 25, 6, 8? Like you can see that how it is not, we are not able to find it near something as well, right? 2, 22, 9. Because all of these different chunks, they still have something common. But 27 was a very random chunk which we added, right? So see, it is somewhere here, like it is very, very far off from all the others. It is very, very far off from all the others. It is kept somewhere on the right side. Okay. So this is the whole idea that how these chunking things happen. And it is just basically made in a way that yes, it is based on some logic. So we can easily just have anything. And that is how my chunk will get created. Right. So let me delete this for the timing now. And this is how your chunks will get created. Once your chunk is getting created, they will be vectorized and we will be able to see a approach. Okay, let me refresh it. Right, start the experiment again and vector embedding. So let us now continue in this learning part. Now, since the learning part is done, next comes the recalling or retrieval part. Here, I would like to easily understand that in the example which I gave you of the exam thing, the way you have learned, right? The way you have learned, you will only be able to retrieve that information. Now, what do I mean by that is with the logic, with whatever logic you have created these numbers, with whatever logic you have created these vector, these chunks. If I now ask you a question, so let's say that, hey, you have created something here. Now I ask you a question related to, let's say if it was DRS LBW, let's say I ask you a question related to penalty, right? So this penalty is some question which I ask you. If we pass this penalty with the same vector model, with the same embedding model, then I will be again getting some numbers, right? I will again be getting some numbers, but it is very, very important that the model should be same. Now these numbers can be something like this, whatever we are getting, I don't care. But the whole idea is that this thing now, because I have learned in a similar manner and I'm trying to recall in a similar manner, I will be able to get it somewhere here. So I might able to get that, okay, this is nearer to the goal and offside chunk because these are related to soccer. And my embedding model, it is smart enough that yes, it is able to understand. To show you this in an easier manner, the first chunk, if you will pay attention here, everyone, the first chunk, it is explaining about what is RAG. Then this is the definition of RAG. Then why is RAG important? Known challenges of LLM. All these things are coming. Let me go to my graph here in the vector embedding and let me just search what is RAG. Okay. See, when I pass it with the same embedding model, I am getting this particular whatever mathematical vector is. Then when I try to just have this here, have this plotted in a similar manner, you will see that how a chunk 1 will be very near to it. So see, chunk 1 is very near to it because again, very easy. I learned about RAG in some manner. Okay. Then if someone is asking the question in my mind map also, I will try to join it that, hey, this is where I learned this thing. So that is why all the chunks which are nearer to it, right? I'm picking up the top 5. So it is totally on me how much I pick. But I am able to get these chunks which are nearer to my question. And chunk 1 is very, very clear because it was the same thing which I'm asking. What is RAG? Just to show you what we can do is let's do an experiment. Let's try to understand, let's say, known challenges of LLM. Like, let's try to search this thing. Known challenges of LLM. Now, just like it used to happen with us when we were in school, if same question used to come, we used to write an answer, right? If I search this, we will see that in this known challenges of LLM, chunk 6 will be nearer to it. For sure, it will be very nearer if our embedding model is good. So, chunk 3, 21, 23, 17, 12. Okay, so this one is 6, 7, 6. You see like how it is still nearer, not the nearest one, but it is still nearer to it because same kind of understanding is happening. Like we are asking the similar question. And again, if we try to just have the same thing, let me just add this whole overall exactly same thing. Like it is coming from chunk 4. When I paste this, okay, so now chunk 4 will be very nearer to it, right? Because we are trying to do some same functionality. We will find that it will be more or less, it might be on top of chunk 4 only, right? So this is the whole approach, everyone, in which we are learning these things, right? We are able to understand. So now to quickly explain and quickly tell you what RAG is, these are the two steps which you have understood. See, this is the exact diagram with which RAG will now be a lot clear. Okay, see, we have the raw data sources. So we get the raw data sources, your science book, your maths book, everything. We extract the information from it. We can have PDF, we can have any OCR, any crawling, anything. Then we form chunks. And we do the embedding here. Right. So this is what we did here as well. We have the data here. All of this is the data. We divided those into chunks. When we divided that into chunks, then we created their vector thing, right? See, then we created their embeddings. So we pass them by an embedding model and we get the vector database. And this is your vector database, which you see right in front of you. Now, when a query is asked, it is passed through the same embedding. If we mess up the embedding here, we will get very, very bad results. Then again, we get the vector representation. Then we try to find what is the relevant data. Okay, like where I'm coming from, where exactly is that data nearer to me. So for example, when now I will just search what is RAG, right? When I will search what is RAG, I will pick up these 5 chunks. I will try to summarize them and I will surely give a good answer. This is the whole concept. Relevant data. We can now pass these results with LLM if I want. So now if I just pick up these chunks, right? So let's say this is where we have the chunk 4. So chunk 4 says it is exactly the same. What is RAG? Let's see another one. Chunk 1. What is RAG? So chunk 19, it is where RAG will be explained a little bit, I guess. Right? So same information is there. Now, if I want a better overall answer, I can pass it via LLM so that it will all get summarized. Now, just to explain why LLM will be needed, when you were able to recall that yes, this answer or this concept in your exam was from this book, you then used to write your answer, right? You used to make sure that you write an answer in an easy to understand manner so that teacher can give you the answer. For example, next time, if you're given an exam and let's say you recall this image that yes, this is how RAG was explained to me, you will be then explaining it in your own words. So that is why LLM might be needed. And finally, then we can give the response. So this is the whole overall pipeline of RAG. 2 steps are there. First is data preparation. Second is data retrieval, right? Second is yeah. So these are the 2 steps. RAG pipeline to store the data, and second steps become query or retrieval. So this is the whole concept, everyone, of RAG. Now again, there are different ways of RAG. We can do the same as well. In future, we will see the practical as well. But with this overall thing, I hope the whole idea about RAG is clear. Showing you a live example. Let's say if I just go to perplexity.com, it's the best example about this. See, if I just ask Perplexity, right, to just see the example, if I ask Perplexity, can you tell who won the IPL in 2025? Let's see this. Now it will have multiple of these sources, right? These sources which it is getting, these are like the chunks, right? But Perplexity, instead of just giving me the chunks directly, it is giving me a well thought and well overall combined answer. So that is where LLM is needed. These are all the chunks which Perplexity got. From these chunks, it got this relevant data. Now again, these are the 10 relevant things. Then it will pass that via LLM so it explain me easily. So just as a good concept, we can ask it a very valid concept as well. Let me go to home again. Can you explain to me about geography of India in points? Now, since I'm asking it in points, first it will try to get these chunks. So it got 10 overall chunks. But then these chunks in itself, they might not be in points. There might be very much, let's say, irrelevant data. There might be repetition data. So that's why I pass it via an LLM. And that is where, again, see, here as well, if you will focus, it asks you to choose a model. Now, this model is not needed for getting the chunks. This model is needed so that you can easily get the overall, this summary, whatever you want. I can just ask it, give me in a long paragraph. So this time as well, now your sources will be the same, right? Sources are again the same. but it is now giving you in a long paragraph, and this is where the LLM is coming into picture. LLM is nothing, just a brain. So the whatever instructions you give to your brain, it will just give that, right? And I think this is exactly what was happening. We have this thing, and now we can ask it for a response generation. So I can just generate a response, okay? And you can see as well, you are a helpful AI assistant. Use the following pieces of context to answer the user question. So when I ask it a question, these relevant context were kind of picked up. Now it is getting refreshed every time because maybe the model is kind of like that. But these chunks are took up, and this is generally what we say. Even perplexity will be having the same thing. So this is the context which went through. Now, since it was having this full approach, it will be giving you an answer, and see, this answer will be very close to this thing, the chunk which it got. The benefit is right in front of us. We can genuinely handle infinite data in this manner. First, second, your LLM can be a lot smarter. It can tell you the answer about things which it doesn't know as well. So this is the whole idea.